Ladies and gentlemen, good evening. It's my very great pleasure to welcome you to the Royal Academy of Engineering and to this evening's special lecture by Steve Holliday, Chief Executive of National Grid. Now, Steve was elected to our Academy last year, and I'm delighted that he's already very active in all the things that we do. He's been Chief Executive of National Grid since 2006, having joined the company in 2001 as an Executive Director, in which role he was responsible for transmission, gas distribution and business services. In his earlier career, he worked with British Borneo Oil and Gas and Exxon, where he held senior roles in the UK and Asia. He chairs the UK Business Council for Sustainable Energy and leads a number of sustainable energy and skills-related activities for business in the community. The Academy and the National Grid have developed a strong and valued relationship in recent years. Together, we're committed to promoting the engineering skills agenda and creating the skilled engineering workforce for the future. Steve chairs the Technician Council, which is hosted by the Academy, and he has championed a range of important joint activities delivered in partnership with the Academy to make a real difference to the landscape for skills. National Grid itself was the first company to make a contribution in the remaking of this building. In recognition of that generosity, there's going to be a room named after National Grid, the National Grid Room, when this building reopens in 2012. Now to tonight. Steve is here to talk to us about power to the people and how we're going to address the energy challenges that face us all. Sustainable, clean, affordable energy will be crucial if the UK is going to create a balanced, thriving and globally competitive economy. And it is right that someone who can actually do something about these challenges, not merely debate them with us, is our lecturer tonight. So Steve, without further ado, I welcome you to give the lecture, and after that there'll be plenty of time for questions and I hope answers. Steve.
Thank you very much, John. Good evening, everyone. There is a significant challenge that faces this country, and in fact, it faces the world. It's a challenge that certainly will affect every one of us in this room this evening. It's a challenge that increasingly is capturing the imagination and attention of the public. And of course, I'm talking about what John was referring to, our energy future. And the importance of this has been emphasised in the last few weeks. As I was thinking about my remarks a few weeks ago, I wouldn't have dreamt of the events unravelling in the Middle East and North Africa, and a renewed concern, acute concern about the cost of energy and the inevitable impact that we know the price of oil has on inflation and on GDP. But in particular, the challenge today for society is how we're going to deliver low-carbon energy to people in our communities in an affordable, secure and sustainable way. And how do we position the UK for economic growth? Our job at National Grid is to connect people to the energy they use. It's impossible, isn't it, today, to imagine life without energy at our fingertips. Everything in our society is built around it, from the warmth and the light that we count on at home, to the power that drives our factories and our offices, to the power behind the mobile communications and technologies that today are just essential parts of our lifestyles. National Grid owns and manages the grids to which all the different sources of energy are connected. In the UK, we run the system that delivers gas and electricity across the country. In the northeastern states of the United States, we have a direct relationship with 8 million customers. We hold a slightly special and I think somewhat privileged position. We sit at the centre of energy systems. We do join everything up. And that puts us, therefore, at the heart of one of the greatest challenges in society today, the creation of this new sustainable energy solution. So it's an incredibly exciting time to be part of the industry and part of this company. And there's some real parallels between what happened in what I would term the first energy revolution early in the last century and the situation we're facing today. The national electricity grid here in the UK was first conceived in 1926 because the government of the day wanted to transform our economy for a modern age. And they saw and they understood the importance that electricity had, that flowing electricity across Britain cheaply was a real way of driving a modern economy, new industries and new jobs. At that time, a costly and cumbersome hodgepodge of electricity companies and local councils supplied electricity, and just 1 in 20 homes was actually connected to a grid. By wiring up the homes and businesses to national grid, at that time, our economic rivals France and Germany were successfully growing their economies and making them stronger. So the UK set about building a national grid. It was one of the biggest peacetime construction programs this country's ever seen. And in 1935, when the system was first run as an integrated system, I like to think of that Britain finally came into the light. And power prices dropped. Industrial productivity went up, and not surprisingly, consumption of electricity very quickly jumped by a third. And moving on to the 1960s, 98% of homes in Britain by this stage were connected up. A huge transformation in our way of life. And by the middle of the 20th century, literally, there was power to the people. And I think it came to embody in many ways their mood of optimism and progress. So where are we today? The situation at the start of the 21st century is slightly different, but it's another enormous challenge. 50 years on, many of the critical assets that were constructed now need replacing. The way that we produce energy today and consume energy today is not sustainable. And society has totally changed. In the UK, though, there's now a political consensus around the agenda and the aim of cutting carbon dioxide emissions. The Climate Change Act requires greenhouse gas emissions to be reduced by 80% by 2050 and 34% by an incredibly early date of 2020. Meeting those challenges, those targets, is going to require dramatic change in the way that we produce electricity. We need to become less dependent on fossil fuels. We need to use energy more efficiently. And in particular, we need to generate a lot of renewable energy and move today from only 3% to 15% of total energy consumed in the UK by 2020. And of course, we'd like to do all of that with a happy consumer and afford it quite easily. I do remember even myself talking about this subject 3 or 4 years ago, and in great danger, as many of us have been, I think, over time, of talking about energy and security of energy, and for National Grid in particular, keeping the lights on. And then we transitioned into talking about the environmental challenge, and we quickly transitioned into talking about affordability, making sure that customers, whether they be households or businesses, don't have to pay too much for their power. And in many ways, we're in danger, I think, then of seeing these as 3 separate issues. But the debate's moved on. It's absolutely clear the issues are interlinked. They're just different facets of the same challenge. Creating an energy solution that is truly sustainable for the future. Recognizing that successful economic policy and environmental policy have to go hand in hand. And when I personally talk about sustainability, I mean it in its broadest sense, incorporating environmental, economic, and social sustainability. But make no mistake, these targets that roll off the tongue so easily are ambitious, and they are very demanding. Our own company, National Grid, in the last 5 years has begun to modernise and replace our networks. A significant part of the UK's power generation capacity is ageing, and over the next 10 to 20 years is scheduled to shut down. 20 gigawatts of generation, a quarter of the current total, will retire this decade. That's as old coal and nuclear stations are shut. By 2030, not that far away, half of all of our power generation capacity here will have closed. So let's then picture the magnitude of the shift that has to take place in the mix and the type of generation. And the biggest shift is away from traditional coal. A third of the generation capacity today is traditional coal. And that has to be brought down from 32% to just 3% by 2030. And it will be replaced, and the biggest increase is in wind power, although there remains much debate. Every day I read another article in the newspaper about the expensive wind power and the sham that it is. But current plans expect 28 gigawatts of wind by 2020, of which 15 to 20 or so are going to be offshore. That's almost 15% of our installed capacity, from today a situation where it's less than 2. And going forward, we see still further wind continuing to increase up to about a third of the total by 2030. So we will have gone from a third of our mix being coal to a third of our mix being wind in about 15 years. However, wind does present new challenges. Its remote location will require new investments, and the intermittent nature requires a very different approach to the way in which we run the grid. And there's a lot of focus today on nuclear. Should it be, in our view, about the same level in 2030 as it is today, about 10% of our installed actual capacity? But that masks the story that 17 nuclear plants today, of the 17, only one will still be running by that time, Sizewell, and much larger plants will be built on the same sites, and some, like Hinkley Point, 3 times the size of the plant that it's replacing. Carbon capture and storage will begin to make a showing, in our view, by 2030, and should by then account for 10% of the mix. The geology under the North Sea is well understood and ideally suited for safe, large-scale geological storage of carbon dioxide. The component technologies of capture, transportation and storage are well understood. As a country, we should take the lead on this technology and solidify our position with a large-scale, end-to-end demonstration plant to the storage field through an integrated CO2 transportation network. And we expect the emergence of alternative new renewables that together are likely to make up 12% of capacity by 2030. But before I talk a bit more about the role of gas in heating our homes, let's recognise that gas will continue to play a big part in generating power. Today, natural gas provides about a third of our generation capacity, and is still expected in 2030 to provide more than a quarter. Let me just try and give you, and I know there's quite a few numbers here, a couple of data points as to why this is such a crucial issue. Today, our electricity generating mix in the UK generates about 500 grams per kilowatt hour of CO2. Coal is 1,000, and we need to get down to 200 by 2020. Gas-fired power generation, unabated, is only 185. It's a key part of our future. But it will play a different role. It's going to serve as backup in the future, backup to these intermittent renewable resources such as wind. And the sources of gas have changed enormously. I continue to think this is one of the great industrial secrets of the UK. We've moved from self-sufficiency in 2001 importing a mere 1% of our natural gas, to last year, 2010, 50% of our gas being imported. And with the continued decline of the North Sea, we forecast that 75 to 80% of our gas will be imported by the end of this decade. An enormous shift, almost invisible to the public. And we cannot ignore the development of shale gas, particularly in the US, and the impact that's likely to have on the global gas market, supplies, and indeed prices. Shale gas accounted for only 1% of US natural gas in 2000. Today it's 20%. By 2030, 2035, many estimates reckon it could be 50%. Another enormous shift in a short space of time. The exact proportions for each energy source in this changing mix are always going to be uncertain. But the emerging picture is a picture that is generally recognised by most players in the industry and indeed government, does give us confidence that there is a trajectory that we can get ourselves onto that can achieve these challenging 2050 targets of carbon reduction. But we're headed for enormous change in the diversity in our electricity generation. And I don't just mean the fuel mix. Generators will be all over the UK and on all the seas around our shores. We have to plan a system with significantly increased flexibility, a system that can manage this enormous intermittency. And realistically, a large share of our energy will be reliant on the weather, when the sun shines and the wind blows. And we need to stop yearning, and I think I'm talking to many of my own engineers as I say this, yearning for our new sort of generation, our low-carbon generation, to be just like the old high-carbon generation and under the control of a switch. Because when it comes to managing the balance of supply and demand, new ways of managing demand and increased interconnection with networks on the continent must play an essential role. And developments in high-voltage DC transmission have not been standing still. Voltage source commutation technology in particular has made dramatic leaps in capacity, distance, efficiency and cost in the past 10 years, is a key enabling technology for greater connection between power grids, and particularly in establishing what we will have in 10 years' time, a large offshore grid. Yet at the same time as we're making this transition, as we get closer to 2050, the demand for electricity is set to soar. It's likely to rise by 50% from where it is today, from 330 terawatt hours last year to 520 plus in 2050. Why? Because we'll be using power for our transport, for our cars, and to heat our homes. And how can we facilitate that? The investment in energy infrastructure will be done with smart technology, or at least smarter technology. Our transmission system in the UK today is smart, but we'll continue to exploit communications and new technologies that will make that system even smarter. But smart gets into our homes, helping customers manage their energy needs, instructing when they're able to charge their vehicles, and lowering their cost by allowing them to play in the market by reducing demand and becoming more efficient on their energy use. But however smart the technology is in the future, it will not replace the need for enormous capital investments. And we can't underestimate the scale, the exciting scale of the engineering challenge that's going to be needed to deliver a sustainable energy future, and one that I believe is going to, and in fact needs to, lead to a huge renaissance in engineering. And as we embark on this transformation, this revolution, we are going to need new technologies. There will be new players in the industry, and we need significantly new engineering talent. Let me talk first about technology. because the development and interest in energy technologies today is phenomenal. I can't keep up, frankly. There is so much happening, not just here, in China in particular. There's almost something new coming through my email system every week about another emerging technology. I couldn't pretend to try and cover all the possibilities. But let me offer up 3 technologies, very different technologies, that unless we take account of, would be disruptive. And the first of those is energy storage. The dream. Not only would energy storage help the wind intermittency issue, it would turn the industry on its head. The electric industry and its infrastructure, regulation, the way markets operate, are built around the fact that the product has to be used the instant it is produced. At National Grid, we've collaborated on numerous storage technologies, including flywheels, pumped hydro, pumped air, and of course, batteries. There is more to be done, particularly in hybrid energy storage, but the level of activity that's required to make large-scale, grid-scale storage is still not, in our view, an available opportunity in the next 10 to 15 years. But there is a lot of focus on this globally today. Electricity transportation is a technology that arguably is already having a major impact, not only on the electric utility industry worldwide, but also clearly on the oil and the automotive industries, and possibly represents a shift in geopolitics in the future, back to my introductory remark. But the last technology, and one that if I polled you, I suspect you would not have assumed I had on my list, is solid-state lighting. One of the major challenges we face is how to get consumers to embrace energy efficiency. I talk about it a lot, the government talk about it a lot, and it's just not happening. Solid-state lighting is a huge opportunity, I believe. It combines energy efficiency with control. Controlling light, whether it's spatially, spectrally, or temporary, drives new innovation. It's not only going to allow customers to use less, but get more for what they're paying for. In addition to those 3 technologies and my comments about the amount that is going on globally, there are new players that are moving in. Last year, venture capitalists invested over £12 billion in clean technology firms. That was a 30% increase from 2009. 4 out of the 5 top VC investments worldwide were in clean tech. In fact, if it hadn't been for Twitter, all 5 would have been in clean technology. And the last piece of the renaissance has to happen with people and their talents, new engineering talent. And the changes on this scale will drive innovation. The first industrial revolution did so. And without a doubt, the shift to a low-carbon economy will do so again. But as we plan the route ahead and have to make these enormous investments based on information we know today, we need to stay flexible and open to adopting the new technologies that will come along and the efficiencies and opportunities that they offer. I have some days in my working life where I feel sad and happy at the same moment. Let me explain why I say that. I meet engineers who work for us who are close to retirement today, and they tell me how they just wish they were just starting out, how disappointed they are just to be leaving at the wrong time in history, because it's going to be such an exciting time to be an engineer. They can see the leaps that the engineering industry needs to make over the coming decades. But we've got to get the policy decisions right. And if we do, then the country can have the sustainable energy future that we all want. And I think we've got reasons to be optimistic. We have groundbreaking climate legislation in the UK. It is truly groundbreaking. The government continues to show great determination to drive the low-carbon agenda. Enormous investments are needed in this industry over the next decade. Ofgem, forecasts £200 billion of investment by 2020. And crucial decisions are being made this year, with first of all the government's review of the electricity market and the regulatory reviews associated with investments in the networks. It is absolutely vital that the right frameworks are put in place that create the right incentives. Investors have to be provided with as much certainty and transparency in this uncertain world as they can. Why? Because that reduces the cost of capital. It makes sure we attract the finance. And we are competing for finance in a global market. We need to make sure that the legislation and regulation which governs investment is at least as attractive here in the UK as in other countries. I know this is a sentiment that the government and the regulator understand, and they're acutely aware that the time is nigh. They've got to get this decision right and this balance right between investor confidence and consumer affordability. And for the industry, our job is to deliver efficiently, spending wisely, keeping costs as low as we can for the country, for businesses and for consumers. But if we're to be efficient and not waste resources, there's a need for a real joined-up approach to many of the solutions that we're developing. Let me give you one illustration. In order to get to that 20 gigawatts of wind energy I talked about, the new offshore wind farms, not surprisingly, have to be connected to the national grid. The current regime for connecting offshore wind generation inevitably leads to the installation of many point-to-point subsea cables connecting each individual farm to the grid. That regime was developed in an environment when our aims on offshore wind were modest compared to what they are today. And in time, I believe that regime is going to be a barrier to us meeting the targets that we've committed to. Without a regime that provides the right incentives, we could be looking at 60 different offshore landing points for wind farm connections in the UK. Each one of those requires a substation the size of 2 football pitches. Now, a number of those connection points are along the east coast of the UK as well. The potential, clearly, for objection and chaos in the planning system is obvious. But not only that, there simply aren't enough seabed routes to onshore connection points to accommodate all the wind that's planned. An alternative approach is to deal with an interconnected system, a high-voltage transmission grid offshore that serves multiple users and is able to adapt to future demands. Such an integrated offshore network would have a number of huge advantages. For a start, we'd be looking at 30 onshore landing points compared to the 60. The cost savings for consumers would be worth between £5 and £8 billion by 2030. And clearly there's a smaller environmental onshore footprint. This larger scale integrated solution would be more able to keep up with our generation and our interconnection requirements as new technologies emerge. And if the government encourages that kind of coordinated development, we could be a major driving force for this now often talked about North Sea grid. Other European countries are also seeking to harness their power of wind offshore. And the most resilient and efficient outcome would be if all this wind were connected via some sort of North Sea grid. Certainly for the UK, allowing us to be an exporter of power when we can't consume it ourselves. I will use the words optimistic again, because I am an optimist, but I am optimistic that this is a subject that government are beginning to understand. But it's a real example of the complexity and the need to join up and coordinate policy. We've got to make sure we do not burden our economy with unnecessary costs. And frankly, we need to do this if we have any chance of meeting these renewable targets. But another example of the need for a coordinated view is natural gas. Gas has, for the last 3 or 4 years, played second fiddle to electricity in the energy policy debate. It's not surprising. We expect, as I've said, electricity generation to be absolutely at the front, at the vanguard of decarbonising our economy. And it's right, therefore, there's been such a focus on it. But we can't forget the role that gas will have to play. But a couple of crucial differences from today. Gas, ultimately, in power generation, will use carbon capture and storage technology. As I indicated earlier, for the next 10 or 15 years, it will play a major role as a backup to wind. But 80% of our houses today are heated with gas. By 2050, although the population will have grown from 60 to an estimated 80 million people, 95% of our housing stock will still be in existence, still be in use, and will still be connected to a gas grid that we have all paid for. Did you know that an average winter demand for electricity in the UK is 1,000 gigawatt hours a day? But the equivalent average energy demand for gas is 4,000 gigawatt hours a day, 4 times greater than electricity, because that's associated with heating our homes and our offices. And of course, in our climate, it's very seasonal and very peaky. So to switch over, as some would suggest, and electrify all of our heat demand, even taking into account a huge penetration of electric heat pumps, we would need to build an additional 45 nuclear plants that would be used for, in a cold winter, like the one we've just enjoyed, 6 or 7 weeks of the year. An enormously inefficient use of capital. The economics and practicalities of complete electrification of heat just do not add up. But heat does constitute over a third of our carbon emissions in the UK. So it is a vital part of this journey of decarbonisation. Energy efficiency is a key way of getting at that. Using less energy is clearly the cheapest way of reducing carbon emissions. So insulation and appliance standards, things that in many ways are not exciting, have a huge role to play. But developing biogas or biomethane around the country can and will contribute to the decarbonisation of heat. At the upper end of our expectations, such technologies could deliver almost half of the gas we use today for heat in their homes from renewable feedstocks, such as waste. And the future will undoubtedly include dual-fuel heating appliances in the home, consume gas and generate baseload heating with electric heat pumps, and then topped up when required automatically with gas. So gas has a crucial role to play in our energy mix right out to 2050. I do think the success in many ways of this debate over recent years is that many commentators accept the imperative of the need for investment. But they do argue currently that this is not the time to weigh down our economy with costs that should be avoided and deferred. And as we embark on this investment programme, as we have already embarked on this programme, we absolutely need to focus on affordability. But we shouldn't underestimate what a shift to a low-carbon economy will do. It will bring jobs. It will bring new businesses. It will bring new technologies. And the UK must participate in that opportunity and the growth that it will lead to. So there's another area of joined-up thinking here that I worry about. It's about the skills that we need. In my business alone, I know the difficulty we have today of finding the number and quality of the right engineers for the job that needs doing. And I know from the things that John was talking about, my business is not alone. And the situation is only going to get worse if we don't ensure that our education system is able to produce significant numbers of graduates and technicians with the skills that we need. One government estimate is that 58% of all new jobs new jobs that are created in the next 10 years require a STEM background, a science, technology, engineering and mathematical background. And 29% of all jobs, existing jobs and new jobs, in 10 years' time require that background. Now, there's a lot of attention on this issue, but somewhat typically, in my view, passionate individuals are operating in silos, and the cumulative effort of the work is not being harnessed. There is not a coordinated approach, and achieving the progress needs a better alignment across the primary, secondary and higher education systems, working in partnership with business. We need to make every effort to bring alive for young people the opportunities that exist for them and the real contribution that these skills can make to tackling some of the biggest challenges our society has ever faced and excites many young children today. And I'm very pleased, therefore, to make those remarks here at the Academy because of the increasingly good work that's carried out by the Royal Academy of Engineering. For 20 years, this Academy has supported organisations that bring engineering to life, make it real in and around schools. And the work has been accelerating over recent years with support from industry and the wider engineering profession to form the Tomorrow's Engineer initiative. But we have to recognise the vital role that teachers have in influencing the career decisions of young people. And the Academy and businesses are working with a wide range of organisations to develop courses for teachers and learning resources that help to bring the STEM subjects to life in the classroom. We've got to bring the engineering profession together with the public policy makers and inspire and educate children into what engineering is really about. Work like that is going to be so important to our future. So, let me bring this right back to where I began. The job of National Grid is to take power to the people. We are embarking on a transformation that will affect us all, and one in which everyone has a part to play. Because as consumers, we will need to adapt our behaviour if we're going to successfully transition to a low-carbon energy future that we can afford. And we at National Grid want people, in fact society, to have a greater say in what we deliver and get involved. And we're already changing, making significant efforts to put on increased levels of consultation in everything we do. Because many of you will know, as I do, that building infrastructure for the future will never be able to satisfy everyone. Just think about our pylons. Nobody likes pylons. Well, actually, if I'm completely honest, I know a few people who do. And they get very excited about the beauty of the structures. But most people are understandably concerned about new pylons appearing across the landscape. Let me be very clear. We don't have an inherent preference as to whether we build pylons or put transmission systems underground. But as a society, we need to enter into a discussion about what we can and what we can't afford. The fact is, today, undergrounding cable costs more. There is much debate, much work going in this space, but conservative estimates currently put the cost at 10 times above grounding. So the pylons are going to have to go somewhere in this country if we're going to have the energy that we so desperately want. And unless we're willing to pay an extra £200 billion for a more expensive solution rather than the 15 to 20, we are going to need to build some pylons. And we will expect to invest in that. There's a colleague of mine who often, when talking about this subject, says, just remember how much a new hospital costs and how many hospitals we could build for the difference between undergrounding and above grounding. And there are always choices to make, aren't there? Getting the balance right, making this judgment for us and future generations about the landscape and affordability, understanding how these decisions impact on each other, and setting out these choices in a big picture of the benefits that we'll deliver to the UK as a whole. And government is looking for communities and individuals to take more power into their hands. And we expect that I mean that people will install energy efficiency products in their homes. There's an enthusiasm already about home generation, solar panels, ground source heat pumps, and the development of waste-to-energy plants. Smart management of energy is going to be part of all of our lives, from the car to the refrigerator, from the heating to the lighting. So you can see why I believe that it's a great task, an important task that we're involved in, and why I'm excited about the role that National Grid can and will play. We have to construct a modern infrastructure that's fit for purpose for the 21st century. We've got to connect these new sources of power generation. We've got to connect people to these new forms of energy and give them the opportunity to play a part in managing their energy use. And we will play a central role in delivering sustainable solutions, clean, secure and affordable, and the critical infrastructure that will underpin enormous economic growth in the next 20 to 30 years. Many of you might have watched the BBC programme recently called The Secret Life of the National Grid. Lovely title. I can see a few nods. But its title captured, didn't it, the fact that many people don't know what the National Grid does or how their energy supply actually works. They just like switching that switch on. In the future, it's highly unlikely it will be so secret. Energy is clearly on, and rightly so, on the public agenda, and the role of my company will become more visible. It's a great privilege, a great honour to lead a company that's full of people who feel so passionately about this new era for energy. But going with that passion is something else. It's a real understanding and responsibility for delivering the energy systems of the future. And we will continue to work with government, industry and communities all over the UK to ensure that we do that. But just as I said, it's impossible to imagine our lives without energy at our fingertips. It's also impossible to imagine the UK without a reliable, modern and smart grid system. Thank you.
Martin Grant from Atkins. Steve, thanks very much. Extremely entertaining presentation. My question is around intermittency. It's a concept you introduced because we're likely to have a lot more wind in the future. You talked about balancing the intermittency of wind using some flexibility in the grid, perhaps bringing storage into play. But my question was more about intermittency at the point of use. So I seem to recall when I was growing up in the 70s that blackouts were pretty frequent due to industrial action. We've since come to enjoy, I'd say, an incredibly reliable supply of both electricity and gas. So I wonder if in the future, intermittency at the point of use might be something that comes into play more. And I'm not exactly sure what the question is. I'm not sure whether it is, should we accept that? Will we have to accept that? Or is it a question perhaps of users who choose to accept some intermittency are rewarded in some way? But I'd certainly be interested to get your views on that.
Yeah, thank you. And it is the last point you make, actually. And I don't have a perfect crystal ball either. I think it's quite hard to conceive of a world where we accept rolling brownouts as a matter of course. You think about how we run our lives today. But I do think, and it's part of this whole smart technology from the meter right back through the grid system, that demand-side management, as it's called, is a huge part of the future. It has to be. People underestimate how much of the system today uses it. We today in the National Grid have contracts with people who take large chunks of electricity, and we have a contract that we can switch them off for a period of time, and their plant is able to handle that. And as a result of that, we pay them a fee annually, and that reduces their energy bill overall. But at the moment, that's done at a very large scale for people on the transmission system. There is unquestionably a world, and my own view is it's probably just after 2020, in which we will all enter into different supply contracts with those that sell us electricity, which is about how often are we allowed to be interrupted and get a discount, frankly. And if you want to sit at home all day long and play a computer game and not ever be interrupted, then clearly it's not a contract for you. If you're happy and you're at work, then it's quite easy to interrupt and switch off the refrigerator and the freezer for 5 minutes or so without any damage whatsoever. And the technology is alive today. We are trialling this in the United States with a smart meter and Zigbee-enabled communications into the white goods devices. So it's there today. One of if I can just continue a second, one of the key challenges we have got, all of us, I think, is when do we invest in this technology at the right time so it's of use? And there's a huge enthusiasm about smart technologies and smart meters in particular, and a drive for all of us to want to have a smart meter in our home by 2016. I liken that to having a DVD player when there isn't a shop in Britain where you can buy a DVD. Yet we need to have a smart meter unquestionably when we've got the level of intermittency on the system that I was referring to, the commercial arrangements have been created, and when we're charging a lot of cars. We can't make that world work without a smart system, but we don't need it in 2015. So one of the big political challenges here in the industry is how can we invest that's commensurate with when we can get the benefit? Because nobody will thank us for charging them for something financially that they don't have a use out of for 5 or 6 years. It is a big challenge, but it is part of the future. It's how we'll manage this intermittency.
So, in the front, and then back there.
Thank you, Mr. Holliday. My name is Ghosh. I'm from AT Consultancy. I've got two-part question in regard to the transmission of electricity. Number one is the use of superconductors, which I read a number of articles about developing, and that superconductivity can be reached at a relatively higher temperature nowadays. And the fact that you mentioned the subterranean transmission costs 10 times more than overhead transmissions. Is it based on oil field cabling or by use of superconductors?
On the second question, no, it's not based on oil field cables. It's based on modern conductors, although there is a lot of work going on at the moment to ensure that we fully understand that delta. It used to be, even when I joined the industry, only a decade ago, 18 to 20 times expensive. We've got those costs down to about 10 times. There's more work going on to actually understand exactly what it is. Because it is part of the public debate. People have to make the choice. There is no question in my mind that there will be sections of our transmission system that are undergrounded, because it's so important for us to protect that piece of landscape. But to underground the totality, as I said, at £200 billion, is not a good use of our money, I would suggest. On the second point, there is so much going on in the offshore area at the moment to do with cables. It's an area in which we are provoking the manufacturers and the suppliers to size up and reduce the costs of these systems. It was only 4 years ago that many of the cable suppliers offshore would say that the maximum capacity they could give us would be about 250 megawatts. We're already at 1,000. And what we'd actually like, given the size of the wind farms, is 1,800 to really drive the cost down of connecting those offshore systems.
So, back, yes.
My name is Norman Haste of Langer O'Rourke, and like many other people in the contracting industry are looking forward to building new capacity. But one thing that concerns me is that there is a rapid pace of change in requirements, in demand and so on. But as we often see, the reaction of our politicians in terms of their decision making doesn't keep pace with the change in demands. Also, the requirement for having many more engineers trained to meet the new challenges that you've referred to earlier on is an issue. And do you think that the government is creating the right environment for the private sector to invest and to create these real jobs?
I want to make a comment, if I can, on your point about the pace of change, because there is It is the great dilemma in some ways. We have to get on today with much of what I've been talking about. We have no choice. 20% of the power stations are shutting in the next 10 years. We have to replace them. So we have to make some choices today on technologies today. But we have to leave space as well for the fact that hopefully there'll be some emerging technologies. That's very easy to say. It's very difficult, isn't it? To make sure that a market both delivers on old technology and yet the right incentives are in place for the enormous amount of research and development that needs to go on. That is a challenge, and it's a challenge I think we'll keep talking about with government as well. So you don't back winners. With all due respect to governments, they've not got a great history of making decisions around technologies and backing a winner. But we've got to back something today as we replace the power stations in the next 10 years. Your second point, that's one of the things I was saying, actually, I hope, about, do I feel there's enough being done? There's an enormous amount of enthusiasm and passion and activity. At times, I worry that it's just not all joined up. Some of the things, indeed, that we're thinking about in the education system in the UK here is not directly linked into the business opportunities and the needs of business today. And this revolution is an enormous opportunity for us to create jobs and skills that will benefit our economy long into the future. And of course, if we don't start to fix that and actually match the demand with internal supply, we all know where those jobs will be filled from. They'll be filled internationally. So, this is a cry, actually, for we should not miss this opportunity. So just as I say, this is a pivotal year, 2011. There are decisions around incentives that will incentivise these enormous investments in both the power stations and the infrastructure this year that we just cannot afford as a country to get wrong. There are also very important opportunities not to miss to join up our education agenda with this enormous investment opportunity and industrial opportunity.
Can I just take the opportunity to press Norman's point if I can? The question, I think, is, are there a couple of things that you'd like to recommend to policymakers, Steve, that they'd bear in mind to make sure that there are right rates of return available for these projects for the future, as we go from a period where I think regulators and everyone's been very advantaged by having plenty of excess capacity to a time when we actually have to renew capacity. Big change.
Huge change.
So
huge
couple
change.
Of points for the 2 points for the politicians and regulators.
Huge change. And let's face it, these things aren't easy. These really aren't easy. But it is about balance. It is about the balance between understanding where capital comes from today, which is international capital and can move globally. So therefore, how do we get a competitive return, but understanding that we have to keep the cost of these things down for consumers. But the asymmetry of getting it wrong, of course, is enormous. Underinvestment, if we don't replace our power stations, we don't actually modernise the infrastructure and the lights go out, the cost to the economy is incalculable. So we've got to err, I think, on the side of ensuring that we are confident and investors reflect that and are happy to provide their money. It's a challenging decision, but it is a decision as well that has to be made today. But it's not a decision that we live with for 20 years. We don't set a return forever, but we set enough incentives in place to allow the providers of capital the confidence to want to come and invest here. And we are in a global market. But it is a challenge. There is a judgment. But there is this need to understand, I think, the asymmetry of getting it wrong, which is very, very important.
Thank you. There, right at the back, Madam.
Hi, I'm Deborah Hoopshire. I work for Shell. Just a question. You talked before about pylons and the costs of new lines. I just wanted to understand if there was an opportunity for local grids to grow to counter that, using maybe local production such as geothermal.
Yes, there is. It's very hard in this subject that's so exciting to cover every aspect, so I apologise for missing that out to an extent. because I think it might sound like, so there is no space here for local generation. In the macro scenarios that both we've created and actually are created by government in particular at the moment, if you go out to 2025, another date actually between two of the dates that I use as milestones, about 15% of the power we use in the UK is generated locally, distributed generation, which doesn't sound that much. By then our power installed capacity will have gone from the 75 gigawatts that we have today to about 112, 115. So that is a lot of power being generated locally. And I'm reminded of some people a few years ago who said, well, we're all going to generate all our power at home, fantastic, we can take all these systems down and everything is going to be local. And like all of this debate, actually, these extreme positions are wrong. Everything is a shade of grey in the middle. There is going to be a lot of local generation and a lot of local combined heat and power where we're building new houses in particular. But we'll still need the big sources of renewable energy that are going to be remote and need to be transferred, therefore, by transmission and distribution systems. So it's not either or, it is both.
There's a question next door. Keith?
Yeah, hi, my name's Daniel Carter. I just wanted to follow up on the response you gave earlier about the need for meters, smart meters coming in, not until much later. Can you talk us through your ideal timing of rollout of technologies to make the grid or the transmission and distribution system smarter? In which sequence do you see technologies being deployed here? Draw us a mental Gantt chart, of timing.
I just must ask, who are you affiliated with, Daniel?
It's a venture capital firm here in London in the clean energy sector.
Which is called?
Conduit Ventures.
Thank you.
I charge for my consulting. I'm smiling, Daniel, as you ask that question, because I think, you give me some credit that I don't deserve for the ability to draw such a mental picture. That what's happening today internationally, though, is very exciting in this space. There's an enormous amount of work going to smart meters in isolation. There's an enormous amount of work going into technology that will measure power flows much better today across the systems. And there's an enormous amount of work that I passed by just earlier, talking about particularly the Zigbal-enabled chips in all of our white goods. And of course, phenomenal research into the most effective way of charging electric vehicles in the future. And these all need tying together. In the United States, actually, one of the things that's quite exciting about some of the Obama incentives to try and inject into the economy is just under $2 billion were put aside to actually work in this space. So there are some pilots that are in operation today. And that pilot's a great principle because you can't design and think about these things in isolation without trying them. And I know that as these pilots unfold, some of the things that we're expecting to happen will not happen, and things that we don't expect will occur as well. But there's a lot of interest in companies that you're involved in, obviously, in some of this technology. The key points are to join it all up. So that was my somewhat sarcastic remark about the meter, charging us for the privilege of a smarter meter, when actually the real deliverable is about how we balance automatically the system too early is wrong. But we've got to roll them out. You can't decide on a Thursday afternoon they'll all be there by the following Monday. But there is a confluence coming forward here, I think, which is not driven by technology. It's driven by when you can really create value from these investments. And as I estimated earlier, I think it's between, for the UK, 2020 and 2022. And that is associated by that stage, the enormous amount of intermittency on the system that we have to get into this management of our demand. And together with, by our estimates, the number of cars that are charging that are not a problem today, as you can see. But when you start to get up to, by that stage, 2 million plus electric vehicles, we've got to be in control of when we're charging those vehicles. There's a fabulous joke that does the rounds in the United States, which is, can you tell the street in California where everyone is invested in in a Tesla, of course, the super fast electric vehicle, to which the answer is, oh, it's very easy to see it. The substation's on fire. And we do have to invest enormously in the distribution systems between 2020 and 2030. So it is about sequencing. So there's kind of half a Gantt chart, hopefully, but it is necessary at the moment that these things are all working in parallel. The key challenge, I think, for government is that we don't cause consumers to pay for something any earlier than they need to.
In the middle hand, I can't see to who it's attached, I'm afraid. You stand up. Thank you very much.
Thank you very much. My name is Brenda Boardman from Oxford University, and it's my job to look at demand reduction. My question to you is about peak demand, because I think in the domestic sector, which is, I believe, about 40% of peak demand, we're doing quite well at reducing our maximum demand, particularly because the average household now has 12 compact fluorescent lamps, thanks to these energy efficiency programs. And I think I'm right in saying that peak demand is dropping. So my question to you is, why do we still need so much new capacity?
Well, peak demand is dropping. It's sadly not quite as optimistic with the figures recently as we've seen. I mean, our overall consumption of electricity has dropped as we went into the recession by 6.5%, and has only recently started to pick up at all. So we actually destroyed a huge amount of demand on the system. If I could take you to our control centre and show you the peaks of the morning, waking up and lighting, and then the evening getting home and switching everything on. It's not hugely different this year than it was previously, although I recognise there are many small things that are happening at a local scale. Why do we need this investment? Well, we need this investment for baseload, not just for peak. So one of the challenges going forward, you're right, is how to use some of the intermittency to help with the peaks and smooth the peaks. But when we start to electrify heat, as we have to, and when we start to electrify transportation, as we have to, if we are to reach this destination of decarbonising our energy, we will need more power generation of electricity. Hopefully, what's going to offset some of the things that you're referring to. So again, one of the hidden things in the data I've given you this evening, by 2030, we believe that efficiency of energy use per head of the population is between 25 and 30% down from where it is today. But despite that, we've still got other things that are driving overall demand up. But there is an inherent assumption in there, which is one of the worrying assumptions, actually, that, well, I'm pleased to hear that you're seeing some good signs, but is that on a trajectory to actually reduce our individual consumption by 25% in the next 15 years? And we've got to do more, I think, to incentivise that as well. Otherwise, the circles don't square as neatly as I've described them this evening.
Great. I'll take one in the front, then one in the other room, and then you, sir, after that. So, please.
John Pritchard, Engineering Council. Steve, thank you for that. You touched on earlier the STEM challenge within the educational area, and you stated that you felt that there was a lot of enthusiasm and a lot of energy being expended in this area to try and head in the right direction from the professions and from others. But perhaps it wasn't being as efficiently used as it could be. If you had a magic wand, what's the one thing you would do to address that and make it better?
Oh, great question. God, don't you just hate questions like that? I think what I would do, one magic wand, is I'd bring education in government under one individual looking after everything to do with education, rather than the way it's split at the moment between the Department of Business and indeed the Department of Energy, in education rather. I'd absolutely give the job to one person, because that's part of the problem, I think, and I'd make it part of the mandate. And the other, if I can, I have two. The other thing that I think is just enormously lacking today in the UK is careers advice. 21st century careers advice in this country is disgraceful. And that's not meant to be a comment to the individuals, it's the provision of information that we give to people. And there's a huge void, therefore. There's lots of work that the Royal Academy of Engineering has done, lots of work the National Grid have done to understand what's in the minds of children and what information they've got. And it's tragic when you listen to the anecdotes and see the data. And we've got to find a mechanism, I think, we, industry and the government, to really provide people in schools with the right information so they can inspire children and really help to guide them, really help to give them advice about the future.
Very good, thank you. One next door.
Hi, Daniel Quiggin from Loughborough University. You've been asked quite a bit about smart meters and smart grids. I was wondering if I could just push you a little bit more to describe how you envisage smart grid architectures and particularly the scale at which they work. I ask this because a national scale smart grid almost seems hugely complex, and distributed generation works on the local or smaller scale.
There's not much I think I can add, to be honest, other than just to go back and reiterate something I said earlier. We shouldn't underestimate how smart our transmission systems are today, actually. You know, they are incredibly well instrumented. You know, there sure is more data we can get on the sag on every line and the temperature in every line, and therefore drive its power loading harder. There's more automation going into our substations and switchgear today than there was 20 years ago, for sure. But the system's pretty smart, it really is. But when you come down to the distribution systems, then you find those systems aren't smart. You know, they don't react and respond automatically. They don't self-heal when there are faults in the system. So there is this enormous investment to smarten the totality of the system from the point of use, from the meter, down into the household, down into the appliances that are consuming power, and then back up through the distribution systems. So it is a total smart system. So, you know, I think it's very easy to get confused and think we've got a very dumb system today, which is not the case. There are elements of it that are incredibly sophisticated today. But if we're to balance the load in the future, we've got to get this notion of a smart system right the way down. And as I said, into the home. You know, the home will be significantly smarter than it is today. And the quite frightening thing is so much of this technology is there today. It's absolutely there today. I'm sure there are people in this room who have the ability today on their iPhone to program their Skybox to record something that they're missing remotely. And that technology, even controlling the power flow in the house, is there today. But the benefit's going to be when the whole system is smart and modern. And that's back to this getting the investments in that are commensurate with the need for them and the benefits over a 10 or 15-year timescale. A challenging problem, but what a fantastic problem for engineers to be involved in.
At the back, sir.
Thank you very much, Steve. A fascinating presentation, bringing all of this together in a short period for us. My name's Richard Coakley. I'm Director of URS Scott Wilson, but also Senior Vice President at the Institution of Civil Engineers. So I've got two questions, if I may. The first one is with regard to a European supergrid and the systems interdependency as we start to get smart grid systems and how we actually gauge against failures of these such massive grids. And the second question is with regard to education and training. And I wonder if apprenticeships might come back, because as a big business, you can look at what the number of people you need and train them in exactly what you want over a long period. And this actually moves around some of the problems that you've notified us of in the education system. Thank you.
There's a very complex answer to your first question. And frankly, I'm not the right individual to give you the details behind the answer, but I will give you the headline. There are about 11 major supergrid concepts alive and well today. If you get on the internet, you'll find 11 organisations have developed their concept for a supergrid in the North Sea that connects Scandinavia, Northwest Europe and the UK. So the fact that there are 11 tells you something. We would be enormously worried if those were really interconnected systems that were synchronized, because of the ability, therefore, for faults to be transferred around very quickly. So our own view, and it's not one of the 11 that's available on the internet, is that these are much more likely to be DC interconnected systems that are spilling over surplus power between those nations and not thinking about a totally connected and synchronized European grid that has an awful lot of problems associated with it, actually. But is there an enormous opportunity to share energy flows when there will be days in the future where we are having to spill electricity, switch off wind farms because we can't consume it unless storage capacity is increased? But it could be absorbed into Europe very easily. And likewise, the ability for us to bring hydropower from Scandinavia in when actually the wind isn't blowing is an enormous cost opportunity for us. On your second point, when I referred to, and hopefully those individuals that aren't here to hear those words, the passionate enthusiasm, but the lack of joined-upness, I was hoping that people would understand the compliment that the passionate enthusiasm was intended to infer. And one of those actually is around apprenticeships. You know, there is a great passion. John Hayes has a huge passion around apprenticeships, and he's absolutely right. But it's not just about apprenticeships. Again, we've got to think about that as a pathway for children in the future. And in my own view, we've got to make sure that children understand that actually that's not a dead end either. That's another stepping stone to many other options, technicians, and in fact on, as many of our apprentices do today, onto foundation degrees and degrees as well. This is, for me, about creating alternative types and pathways for education. But apprenticeships play a huge part in our future.
One in next door, please. Next.
Hello, my name's James McKeamy. I'm representing PodPoint, which is an electric vehicle charging infrastructure firm. Electric vehicles have come up quite a bit so far. I wondered if I could ask, what are the specifics in terms of what National Grid intend to supply moving forward when we get towards 2020 and you feel it'll be a factor? And secondly, do you consider National Grid's role as simply a supplier, or do you feel part of your responsibility is to drive consumers towards electric vehicles?
Well, on the latter point, it's very interesting, isn't it? I think, you know, part of our role, unquestionably, because of the privileged position that in many ways I think we sit at, and the way we look at the inevitability of the answers to squaring this conundrum of affordable, clean, secure energy supplies, part of that is, as I hope you've gathered this evening, an enthusiasm for the electrification of transportation. And I think hopefully we're playing that role today. We're certainly playing that role in policy decisions and discussions here. In our business in the United States, we're playing a more active role because we own the distribution system. So we have smart pilots where we are charging vehicles. We have 3 vehicles in our fleet, which are wonderful vehicles. Every time I've been in them, the driver continually thinks he's stalled the engine. He's constantly trying to switch it back on, and of course it's still running. It's amazing how long it seems to take people to get the hang of it. So hopefully you are getting a sense of my passion and our passion that is part of our energy future, unquestionably. But our role in an engineering sense is to understand the power requirements on the system that will need to be met when we electrify transportation, and understand the time of day of charging and how we will actually balance things. That's where I see our real focus. And that goes back to these comments on capacity, first of all, the comment that the lady made about the need for the level of power generation in the future to make sure we've got enough capacity on the system. And if I had a graph here of our view of the demand day in 2030, it does look very different than from today as we reduce the peaks and fill in the troughs with the charging of electric vehicles in particular. That's where I see our role. And I see our role in making sure that the distribution systems in particular that need to really expand their capacity after 2020 begin to understand that we put the right capacity in the transmission system first, and then we increase the capacity in the distribution systems so that we can charge vehicles probably at home, but certainly in the streets and not in just a few isolated locations.
Gentleman at the back, and then second user.
John Blyden, I'm a retired academic. Most of this discussion has been about enormous consumptions of electricity, and quite rightly. Solar power is hardly going to be a substantial contributor to the energy balance, but I'd be interested to know what you think, given that the signals that are sent out by companies and government and so on should at least be pushing us in the right direction. What really is the economic sense, because it baffles me, that if you have solar power, you're paid 3.5 times as much for selling units to the generators than you have to pay them to sell you electricity?
This goes back to the point and the challenge about getting incentives right, actually. And there are several examples of this. The first example I'll give you is in Spain, actually, where the government introduced feed-in tariffs to incentivize what became a huge revolution in solar power, rightly so, in Spain. And then 3 years after the event, suddenly realised we've got more than enough solar power now, we need to take the incentives away, and of course have burnt, excuse my pun, a lot of the investors there. And we've got some similar things happening in the UK with the introduction of the feed-in tariffs that you're referring to today, and now a review going on about perhaps they're slightly too rich, given the number of people that are applying to convert an awful lot of farmland onto solar parks, which doesn't quite make as much sense in the UK as it might do in Spain. So this is a great example of the difficult job, frankly, of getting the right incentives in place and making them robust. We did a piece of work a few years ago, which I found incredibly interesting. I have no idea. I doubt we did it, but we asked someone to do it for us to inform us about the opportunity in these scenarios that solar power could contribute in the UK. It's a fabulous piece of work that would have been impossible before the advent of Google, and Google Earth in particular, because we looked at the location and the angle of roofs in all the existing housing stock in the UK and said, let's cover those that are south-facing in particular with solar panels. Not a lot of use of putting on the north-facing part of the roof. And let's calculate the maximum amount of power that you could generate if you literally installed that on all the existing housing stock, much of which, as I said, is going to be around in 20 years' time. Less than 2% of our requirement. But like my other answer, it's not black and white. It is appropriate at the right time. And one of the policies that I would personally support, I think, is all new housing. There is no doubt, heat pumps on new housing is absolutely an economically sensible decision. And solar power on the right-facing roof, also on a new house, rather than a retrofit, is the right thing to do. But to try and incentivise to the extent that we've got on some of those things, is indicative of just how difficult some of these challenges are.
Keith Glover, University of Cambridge. I think the first part of my question you just answered to the previous question, which was on government policy and which present policies gave perverse incentives. And I think you've given a number of examples of that just now. And the second part of the question is, which future unintended consequences do you most fear?
I do want to make sure that these remarks are taken in context, actually, because these, it's very easy for us to criticise some of the decisions that have been made in recent years. As I spend, because of our business, a substantial amount of my time in the United States, we should be quite proud of the UK. The climate change bill, energy policy is not a political hot potato here. This government and the previous government have taken some pretty brave decisions, actually, and mapped out something that is challenging, which, if you look at many other countries around the world, is not the case, and yet have done so whilst wanting to preserve all the benefits of the markets that we enjoy so much here in the UK. So it's easy to pick the ones that aren't working so much, Net. I think we've done good job of policy here. My challenge is, as I've said on several occasions, there's some pretty big decisions that need to be made in the next 12, 18 months, and they've just got to be right. The unintended consequences, I think, without having the time to go away and think about it and come back to you with a better one, I think is this conundrum of needing to get on and invest and incentivize. It's almost linked to an extent, the technologies that we know today, and the danger that we exclude the incentives for the enormous innovation that can be around in the next 10 years. And if we delay today and just focus on let's put enormous incentives in for technology and innovation, and we can't do that either. So I fear that as an unintended consequence actually is that we focus very much, and as we do, as we scale up, we drive the cost down of carbon capture and storage, costs of transmission and wind will come down over time as well, but we miss some real niche opportunities because we're just blindly driving ahead. That would be the one I'd pick on tonight.
I'm going to take two questions more, one in the other room, and then you, sir, you'll be the last.
Hello, I'm Alec Brewers. I'm a fellow of the Academy and member of the House of Lords. I'm leading on from Keith Glover's question in many ways, and I see one of the real dangers of unintended consequences is that we've got our cost estimates wrong. And my question to you is, how reliable and accurate do you think they are? If you put simple numbers into offshore wind, you come up with factors of 4 or 8 times more expensive than some of the competitor technologies. And my question is, are you happy with that balance between having to get on with it and leaving some flexibility? I mean, it's an impossible question, I know, but how accurately do you think you can estimate the cost it's going to be of distributing wind energy, and especially offshore, where do we understand the maintenance costs as well as the intermittency and distribution?
2 points, if I may. The costs, I haven't referred to costs in a sense specific to wind, but National Grid does not generate electricity itself. So the costs, therefore, of the generation that we use as we look at these issues are provided by those companies that have great expertise and invest there. And there are no doubts, I think, that the costs of offshore wind have gone up recently because of the price of steel in particular, and understanding some of the civil engineering challenges of building in deeper waters. But I also know from engineering past that we will find ways of reducing that cost as well. But will wind ever be on the system at a price equivalent to nuclear power? No, it won't. But it does go back again to the diversity of supply sources and the fact that if we need to, and one of the figures I didn't mention, I know I mentioned the fact that we need to get down in our generation fleet below 200 by 2020, 200 grams of CO2 per kilowatt hour. The equivalent figure in 2050 is 15. 0. So we are going to have to generate power from sources, from fuels that don't produce any carbon dioxide. And when you compare the costs of wind and the total cost, which is the key point that I agree with you, is therefore the cost of transmission and the cost of balancing the system on there. It is expensive, but it's a necessary part of the mix. Our challenge is to make sure that the transmission systems that we're building, as I referred to, are as simple as possible. And there's a huge opportunity with coordination here to reduce that cost by some £5 to £8 billion over the next 15 years. And likewise, the demand-side management and smarter technologies will significantly reduce the cost of balancing the system that's there today. So when people argue today about the all-in cost, if I can use that expression, they are rightly looking at the cost of constructing the offshore wind farm, the cost of the transmission system, and the cost of balancing the intermittency. The latter two can come down significantly over time.
Last question, sir.
David Hughes, the Business Innovation Group. I'd really like to follow on from Lord Brower's question, but from a slightly different angle. You seem terribly positive and certain about your forecast for what's actually happening, and it would have seemed to me that there's a lot of uncertainty in this area. And the uncertainty I'd like to pick up is around electric vehicles, because I was surprised in your comment that you said unquestionably we're going to have these things. Two reasons. There have been serious studies done at Cambridge University and by Ricardo, which are quite clear that the internal combustion engine has a lot of mileage to go and can meet the 2050 requirements simply through efficiencies, different cycles, lighter weight vehicles, and so on and so forth. That's very attractive from an automotive manufacturer's point of view because they've already sunk the investment costs. Secondly, electric vehicles as they currently stand are not fit for purpose for most people's applications. Now, we can argue whether electric vehicles will come or not, but the point is, it seems to me there's a lot of uncertainty in that angle, and if you've put in capacity around those areas, then you could be very much mistaken. I would have been more impressed had I heard you say there's a lot of uncertainty and we're going to map it as we go step by step and take our strategy forward step by step.
Well, I would like to agree with that last point vociferously. In trying to paint a picture of the challenge, I have created for you a scenario. It's a scenario that's not just a national grid scenario, actually. You'll find the government and many others are looking at the sort of scenario that I've described this evening as a likely trajectory for the energy mix in the UK. It's hugely uncertain. And that's part of this challenge, isn't it? Is how do we begin to move towards it and recognise that we're going to have to flex these plans? But it has to be based, like any scenario, on a set of assumptions. But it is uncertain. So if I've given you a sense of this is the answer, then I've really failed miserably this evening, because that's not what I intended to do. But I would disagree with many of your points on electric transportation, actually, which is probably not the time to do so in front of the audience. But I think we've reached a tipping point. I think the car, and one of the things you said, which I completely agree with, is the car manufacturers. And I've been involved, and I know Lord Brown has, on some energy panels in the past, where it's very clear that the position of the internal combustion engine has got a long way to go, was very much in the forefront. There has unquestionably been a shift in the last 2 years. An enormous amount of investment has gone into it, and I do think that there's a tipping point. I also think that some of the stats around the availability of distance for cars as well is very dependent on the country in which we live. The average mileage driven in the UK is quite small, isn't it, as you well know. So there is an opportunity, enormous opportunity for lots of electric vehicles. But this, again, isn't black and white. You know, for those vehicles, particularly road transportation, then I don't see that being electrified, big trucks and lorries. The question there is, how do we make the engine more efficient, and how do we clean up the fuel? So in these models, when you start to strip out, yes, there are internal combustion engines still around, but a significant percentage, I believe, of our vehicles will be electric in the mid-2020s. And that's a point I guess we can disagree on. But the fundamental efficiency of that motor, and the fact that when you look at the carbon emissions, it's very hard to hit the targets that we've actually set ourselves without a huge shift onto electric transportation.
Steve, thank you for this evening. I think you've given us a tremendous amount of food for thought in what is a very uncertain area. I'm reminded by a survey that I participated in a few years ago, not that long ago, where we asked people in California where they thought electricity came from. And of course the uniform answer was from behind the wall. I think, while amusing, I think it actually demonstrates a problem which is, I think, more widespread than California, which is, where do people really think our electricity comes from, and what do they think it takes to get it to them? I think we've heard a lot about that tonight. We've heard about changing sources of supply, renewables, changes in the whole fleet of generation, and the introduction of an extraordinary change in natural gas. I think those of us who've been in the industry just remark to ourselves that in 5 years to have changed an entire viewpoint of how much gas there is in the world says that in another 5 years we'll think about other things as well. There are absolutely no certainties. But one thing is for sure, is that a lot of gas which competes on gas reduces costs, and that's right and proper, and that gives great advantage to the United States of America. Let's hope we can do that here. Second, on demand, we've heard a lot about efficiency, we've heard about smart grids, but we've also heard about the structure of demand, and the structure of demand is, of course, radically changing. The last question, I think, explained that clearly. Thirdly, we've heard about people and skills. I suppose in an industry where people did think the electricity came from behind the wall, and actually there was a lot of it, why would people go into this industry? And so we lost a lot of people. We lost a tremendous number of people who really did know what they're talking about. And I very much hope that they come back into this industry, as I believe they will, because this is one of the most important things we have to maintain and improve standard of living and competitive advantage. And finally, we talked about politics. I think very complicated, for it is easy to ask politicians to be clear about their purpose, and very difficult for politicians to do so. But clarity of purpose, I think, in this area is very important. What is it that's being done? Is it to allow the market to deliver? Is it to impose choice, things like electric vehicles? Is it to impose boundaries, as are inevitably imposed, on cleaning up the environment and reducing carbon emissions? And is it boundaries to do with the meaning of security? These things, I think, are very complex. No one's got it right yet, but with enough tries, I'm sure they will. And finally, it is about, of course, coupling the incentives for investment along with the reality of investment. It's all very well incentivizing solar panels, but it's a good idea to have great sunshine. Steve, thank you very much for a tremendous evening. Ladies and gentlemen, thank you for your 14 questions, and we're adjourned. There is a reception next door. Thank you very much for coming.